Welcome back. I'm Chris Sikora, and I'll be your guide through this exercise 10 using SolidWorks 2020. This exercise, what we're going to take a look at is a bit of an advanced topic, actually, even though this is for the introductory class. We are nearing the end of the semester, and this is what I used to call you might say, real world scenario, or at least as real world as you're going to get as far as the documentation and such. Now, what this is it's actually a rather old MP3 player, as you can see here, about yay big, and it would have been like attached to a belt hoop or something back in the day. I actually designed this just for this lesson. I want to say almost probably around 2003, so it's getting up there in age. One of these days I'll update it. Anyhow, it seems to do the job in getting students to understand like what to expect when you get out there into a job. And this one really kind of makes you think. It's I throw it at you. I don't give you any instructions, or I give you basic instructions that you might see from actually a manager. And I'll show that to you in a second. And then you have to go ahead and do the tasks. Now you'll see that there's on here, and this is in the training guide, which is at vertanu1.com. You could, it's just the SolidWorks Basics training guide, and it's on page 94. Basically, imagine you start a job and someone throws you a project that's like more than, maybe there's only about 10 or 20% of it left to complete. And these are all little details. So, and it's going to be also bottom up and top down. So a combination of the two. Like the bottom up segment will be a battery. You're going to put a AA battery in here. And so you could either model the AA battery or find one online. Most students who I've had who actually ask me, like, what are the dimensions of the battery? There's a drawing I have of it. But think about it this way. You want to be very resourceful in the company that you go to work for. And if there's something like a AA battery, if you could look around the office and see if you have one and just measure it really quick, it's really just a cylinder and it has a little nub at the top. So it's just really two cylinders stacked on each other. And you'd be able to model that up. The one I have on here is a little bit more detailed. But needless to say, I get a lot of students still online because I didn't always include the battery with the assumption. I used to actually want students to model it up. And in fact, actually, the first couple times I did this lesson, I would hand out a bunch of batteries and calipers, and they would measure it. So those are the types of things that when you get out in industry, sometimes it is good to ask a manager. And they might say, gosh, we have one already saved someplace. But if not, just be ready, especially something that's this easy that you can model up or even look for the specs online. You might not want to bother your manager, because remember, when you're hired by an organization, they're hiring you to make their job easier. And if you're asking them questions on how to model a cylinder with a little nub on the top, i.e. a battery, they might kind of raise their eyebrows, and they'll give you a free pass on a couple of those. But after a while, especially if you're new, you might not find yourself working there much longer. So my little piece of advice is do as much as you can that when you can think it through versus always going to ask the manager. And that's a lot of what this lesson is about. And I'm going to discuss some of those aspects. All right, so we want to download this file, and where you would find it, just go ahead and go to Vertanu, V as in Victor, E-R, T as in Tom, A, N as in Nancy, U, X, and then 1.com. And then you'll go to Part Files, and it's going to be the exercise 10 in the red column. The SolidWorks files are always in the red column. Click on exercise 10, and you hit download here. If you're using a different browser, your download button might be up here. It depends on the browser. Sometimes it gets positioned in different places. But anyhow, you want to download it. It's going to be zip file compressed. So when it does open, you could open it with Windows Explorer. Like in this case, it's asking Windows Explorer. Sometimes if I'm in Google Chrome, you could just open it up inside the files there. Hit OK. And now you have the ability to go to extract, or I've shown you in other lessons where you just select everything, or Control A, and then hold Control and hit C for copy, and then create a new folder. Right click on Documents here, New Folder. Oops, let's get in there. There it is, New Folder. I'm going to click on it twice to change it. I'm going to go ahead and label this E10. And actually, I'm going to drop into my SolidWorks Basics folder because that's where I've been keeping a portfolio of things. And then just find the E10 folder. And actually, I already had one in there. And you just right click on the folder and you just paste. And once you paste it, you'll get the part files in there and you can enlarge them. All your images may not come out the same as mine because I just saved them about 15 minutes ago when I was throwing this lesson together. All right, so what we're going to do, if you go into that folder, if you have SolidWorks started up already, that's great. If not, this should launch it. Just find the E10 import and double click on it. It should launch it inside SolidWorks and update the assembly. Now, I'm going to turn off my real view. And what we see here is our MP3 player, and it's incomplete. Even though you look at it, it might seem complete, it's not. It's missing the LCD screen right here. Okay. It's also missing right here. There's actually a hole for a post that would be in there that would create a hinge. And that hinge isn't capable just as yet because we need the post. So a little boss that's going to fit inside there. Some of the other things, if we look inside, you're going to find there's other entities that we're going to have to address too. Now, this is actually spelled out in the training guide. So this is what you get. Now, I'm going to go ahead and rotate this. And this is what we call in industry a red line and markup drawing. It's a drawing that basically goes through and the manager takes a Sharpie red marker and literally, or a red pen, and circles areas, draws arrows, and tells you briefly what to do. So it's giving you your tasks. Now it's up to you to funnel through those or filter through what you know you can do, that you're capable of, and maybe saving the things you're not capable of for a little later on, depending upon how complex the model is. What I mean by that is what I was talking about earlier. There's the AA battery. Not just says made a AA battery into the socket. Again, you could spend some time, interrupt your manager, say, hey, you know where that AA battery is? Do we have one on the file system? Or knowing that it's a very simple part, you could just go ahead and model it up, finding one maybe on, usually they're sitting around somewhere in a radio or in a clock, and you could just pull it out and find a scale or calipers and measure it. Now here I've already made it for us, so we don't have to worry about that. So that would probably be our first thing to address. Now you see here what I was talking about earlier, create this boss that holds the earphone case. And that's like a case that swivels out. So you can wrap up your headphones, stuff them in there and close it up. Now we're not going to go into the engineering aspects of it, like, you know, whether it's a mushroom clip or all the details like that. We're just drawing the post so you get the idea of the combination or this hybrid of assembly, which is essentially top down and bottom up all in one. Then we're going to model the LCD screen, and that's actually just going to be on this circuit board that's right here, the PCB. And then we have to model in some of these details on the backside. So it says shell this backside out at 100 thousandths, add a 50 thousandths by 0.1 inch high lip, all right, with 1 degree of draft. Now, I used to have everyone put the draft in. You don't have to do it. I can't even really see the draft on there, but in real life, you would put some sort of draft typically on there so it could pull from a mold. And then finally, you have add these ribs to hold the battery in place. So that's a cradle that you're building on the plastics, the back side. And you can't see it right here, but on the circuit board, there's actually some circuitry, and then there's a cradle that's mounted on there that we're going to match it up to this so that we have a nice fit. And again, this is, you're going to see some of the power behind top-down assembly modeling, where you could actually take edges and geometry from one part to build the other part so that there's a very high tolerance between them. Okay, and so let's begin with the battery. What you want to do for the battery is roll this around, rotate it, click on this part and hide that part. And now you can actually see there's our cradle right here, and there's some of the circuitry. And this is not a real part, by the way. This is a widget. I just threw this together, so it wouldn't really look like this inside, I'm sure. It'd be much more simplistic. Anyhow, what we're going to go ahead and do is drop in the battery. So if you go to Insert Component, and we're going to go ahead and find that E10 folder, and there should be a AA battery in there. Go ahead and open it up and get it close in proximity. Now, this particular file has the origins turned on. That's what those blue things are. We don't really need to see those if you don't want to. Just go to View and Hide Show and turn off origins. Excuse me. And now we're going to go ahead and mate this. Now, we've learned how to mate with the Alt key. So if you hold Alt, grab either this face or this face, drag it down to that yellow face there, and it should snap. Now notice it's not exactly in place, but it is concentric. So release the mouse button first, then you could release Control and hit the green check. Now we want this backside face to contact the contact. So let's go to Mate. I already have that backside face selected. Go ahead and select this gold contact right here, and it should touch it. Now you could do the other side. Either one's fine. So that's the battery. Now we're going to go ahead, flip this around, and let's address putting in that boss. Now, first of all, the battery, let's ask a question here. What do you think it is? Bottom up or top down modeling that we just did there? And we've talked about both over the past few weeks. If you've guessed bottom up, you're correct. Bottom up is taking parts that are already existing and just dropping them in. So library parts, like also what would be included in there, like nuts, bolts, washers, those are library parts. So that would be bottom up model. Now here's what we're going to be editing this part. And this is really part editing inside the context of the assembly, but at the same token, it is assembly modeling because we're going to base the location of our post centered on that hole so that it fits perfectly. So here's what I want you to do. Now what we have to do is we have to click on the purple part, and you want to go to Edit Part. You always have to do this, and we've learned that from exercise 9. So click on Edit Part, and so now we're editing the purple part. Now one defining entity is that the part that you're editing on the feature tree always turns out the text is blue. So just be prepared to look for that. And you can see it's called the original here. That is the front cover, and it's in blue. That's an indicator that that's the part we're editing. All the other parts are not being edited, but we could steal information from them still. So let's go ahead and notice you can select through the part that's over it because it's transparent. Now start a sketch. Now here, unfortunately though, we can't select through it very easily. So let's hit our space bar and go to the front view orientation, or just so it's aligned here, let's go to front over here, Control 1. Zoom up to that region, and now let's go to either wireframe or hidden lines visible. I like hidden lines visible. And now we can actually see that area there, and you're able to snap to it. So go to the circle tool and align to this. I'll hover over the edge, and then it locates the center. Click and drag out a smaller circle, and you'll notice we're in inches. I'm sorry, metric for this one. So go to Smart Dimension, and that's not a problem. And in fact, when we add our dimensions, you'll see that it's an ISO. So technically, this assembly was not in the ANSI standard, which isn't a big deal. I'm going to show you some neat things. First of all, you could click over here to drop that. And if we're not sure, if we know what it's supposed to be for inches and not metric, you could type in what you know. So for example, 0.120 and hit the green check mark. All right, now it was supposed to be 120 thousandths of an inch, and you can see it's much smaller. So double click on that again. Let's do something different. 0.120 IN. Type in I for inches, N. Hit enter. And it converted it to 3.05. So be aware that just by typing an IN or even just the quote at the end will actually convert it for you if you're in that specific units, the other units I should say. Now at any time you could go over here where it says MMGS, click on it, and you could go to IPS. We don't want to do that. We could, and it will convert over just fine. Now be aware, those of you who worked on older systems had a tendency to rescale them. They actually come out to a different scale, and then you have to scale them yourself. SolidWorks actually does the conversion. So when you change it over, just like when we plugged in the number, it'll automatically make it the proper size. There's no scaling involved, so just be aware of that. Okay, now we could go back to shaded with edges and rotate this a little bit, and let's go to Features, Extrude Boss Base. Now let's say 5 millimeters here, and we can see there's a bit of an intersection. That's okay. Technically, this would be designed better. It wouldn't have that strange little thing. The molding company would actually put a core pin that doesn't have that detail in there if you ask them to. So let's just pretend that that like squiggly area is not there. Hit the green check, and there it is. We've just added a new post. Now when you're done, you have to turn off Edit Component. So make sure you go over here to Edit Component, turn it off, and it's no longer being edited. All right, let's look at our instructions from our manager. So we've taken care of the AA battery. We've created the boss. Now let's hit the LCD screen here. So for the LCD screen, it needs to be roughly the same size as that opening, and it's going to be from the floor of the PC board, that green board there, and it needs to follow the contour of this purple exterior. So to do this, here's what I want you to do. Get it to where you can see inside there. Rotate it similar to mine if you can. And now, underneath Insert Component, hit the little arrow and go to New Part. So here we are at Top-Down Assembly Modeling. Select New Part. Click on the circuit board because it's flat. We can sketch on it. And now it goes to this transparent mode, which when you're more fluent with the system, it's not so bad. But for new users, especially in the basics class, let's go to Assembly Transparency and turn on Maintain Transparency. And then rotate a little bit or zoom in and out for a quick second. It'll refresh the screen. You'll notice there's an opaque assembly, and you're saying, well, why don't we use that opaque assembly that's over here? The reason I chose Maintain Assembly Transparency because it's the best of both worlds. Notice right here, I'm able to keep this cover transparent, and everything else is opaque, i.e. it's solid, you can't see through it. If we went to the that other option, it makes everything opaque, so you can't see through anything. So this is just kind of a nice little feature. All right, now what we're going to do here is we want to create this part similar to how these parts were created, not in the context of the assembly. Well, in the context of the assembly, but not integrated into it. We want to rename it, in other words. Now, while the part is being edited, let's go to File, go to Save As, and it's just going to give a little message here. You could read it if you like, but watch this. Hit OK. And we're going to call it the LCD. Let's copy over the old LCD. Or you could call it LCD1 if you want to keep that other one there. Hit Save. I'm going to replace it, yes. And notice it's now listed as LCD. All right, so we changed it. And now that's a part floating outside of the assembly because we saved it like that. We did a Save As. And remember, we had to be in Edit Component in order to do that per part. So that could be a solution for some of you if you're wanting to change out parts and things like that. Okay, or add parts to it. Now let's select this edge. Now be very careful. Make sure you're getting the edge and not a face. the way you know you're getting an edge is to the right of the pointer, there's a vertical line versus a blue box. If there's a blue box or square, you're getting a face. So stay away from the face. Make sure you get this edge, and the edge will highlight in orange too. Click. Now we want to project that onto our green circuit board. So we can actually do that. And oh, in fact, what had happened is we're still in the sketch, never mind. Okay, while that's selected, I released my mouse button. Now, if you go to convert entities, it's going to be the same diameter. And that's a coincident face-to-face fit, which it might not fit very well. You might want to have some clearance in there so when it's being assembled, it could be put together easier. So let's put an offset entities in there. Now, the offset, if you hit the reverse checkbox, you'll see the offset goes to the inside, and that's what we want. We want this lens, the LCD screen, to be smaller than the hole so it fits in, but not by a whole lot. We're just going to make the offset 0.005 IN for inches. Hit enter, and it should appear to get a little bit larger. And you can see what that conversion is. It's 0.127 millimeters for the offset. Go ahead and hit the green check. And now let's go to Features and Extruded Boss Base. Now, if you were to extrude this by grabbing the arrow and using the ruler, you'll see the preview shows it's not following the contour of the purple outside surface. And we want this to be nice and smooth so if it brushes up against anything, it doesn't get caught. And if you put it in your pocket so it doesn't feel weird. Okay, so now instead of blind, hit this little arrow to the right of blind and select up to surface. Now you just select the surface you want it to go up to right here. And you'll see it will actually show you a contoured surface that it's matched. Go ahead and hit the green check. Let's put a fillet around that edge. So go to the fillet tool, or better yet, actually cancel. Let's put a chamfer. Now, when it comes to aesthetics of a model, a chamfer versus a fillet. If you're dealing with aesthetics, chamfers cast a greater shadow on something. So it's kind of like if you've ever seen actors, and if you look at them up close, and for when a play is being done, they put a lot of makeup on, so you could see them from a distance. And chamfer can kind of do that. Versus a fillet doesn't cast as great of a shadow. So just from a standpoint of industrial design, we'll go with chamfer in this case. And it's just a matter of taste. Let's go ahead and set it to 0.03 and then inches. And this time put the quote in just for the heck of it. The little quote, which is right next to the enter key, shift, and the little button to the left of the enter key. And select this edge. And you'll see the little break in the chamfer. And actually, in here you'll see it's 0.03. Actually, let's increase that 0.06. Now, here's what's interesting, and I just realized the new part that I added, because the way my computer system's set up, or my SolidWorks is set up, we're in inches now. Remember, we were just in metric. That's because the assembly, the imported models were all set up in ISO standard and in metric, MMGS. New parts, it's not inclusive. If your system's set up for something different like that, you're going to get the opposite. And that's okay here. In this case, if we knew what it was in metric, we could type in like 0.0 blah blah mm for millimeters or whatever, or 1 or 2 millimeters. Okay, so hit the green check, and then we have our chamfer on there. Okay, let's turn off editing that component, so don't forget to turn that off. All right, now we're getting here. The next thing is to work on that rear cover. So we need to bring that back. So find the base cover, click on it, and click on the eyeball, the big eyeball, to show component. And let's hide the purple part. Click on the purple part now and click on the eyeball with the line through it to hide it. And we'll leave these other parts in here and work around them. So for this next one, let's go ahead and select this face. And we want to go to Edit Part. So or letting SolidWorks know, hey, we're checking this part out. Let's work on it. So click on it. And the first thing the boss asked us to do was to put in a wall here, or a thin wall. And it's 100 thousandths shell, so 0.1. Now we have to make sure down in the lower right, you'll see it's an MMGS. If you like, we could hit the little arrow and change it to IPS. And now when we go to our shell tool, it should, and sometimes you'll see because the assembly is in metric still, this is only adjusting the part we're editing. So we've converted that part to inches, but the assembly is still in metric. And so you might see like a discombobulation. You might have the two systems. At some point you might see metric, some point you might see inches, just like we saw earlier. But let's see what it gives us. Go to shell, and we're in inches. Okay, and 0.1 is what we want. Click on this face and hit the green check. Now here you get a message, and this is actually common. The thickness value is greater than the minimum radius of curvature. The shell may not succeed, but could cause undesirable results such as bad geometry. Now, it will basically, it's saying it's probably going to work, but there might be bad geometry. And what does bad geometry mean? Well, bad geometry means that maybe there's a little segment somewhere that the face is missing. And normally we have watertight boundary conditions here with SolidWorks. When a face is missing, it's no longer watertight. It has an opening in it, or a crack in it, you might say. And so where that comes into play is if you send it off to a plastic injection mold shop to now make the molds for you. They use these models typically, and they will actually use them to cavity blocks of steel. They might run into an issue where it says it cannot create the cavity feature or remove that. And so that's one of the downsides of this. But they can usually fix it. I used to get these a lot when I worked in industry. I worked in the mold industry for a little bit, and actually the prototyping industry. So I have a bit of experience in this field. But if we could fix it, that would be much better. So let's go ahead and just hit OK and let it do its job. But let's take this out of the assembly so we could look at it without all this stuff around it. And what you can do for that, you could right-click on the actual part, either in the feature tree or right here. And in the quick launch toolbars, the very first tool will be Open Part. Go ahead and select it. And now you might get this message, do you want to proceed with feature recognition? And this is because this will usually happen if it's an imported model that may not be native to the software. We're going to hit no. All right, and so we could see here, now there are tools for checking them and things like that. If we go to imported, since it has a shell, we can't do it unfortunately. But if we left pre-shell, there's actually a little toolbox that allows us to work on it. There are other tools that we could look at it, but I'll tell you right now, usually, and the part looks actually quite good, look for entities like this. So what we have here, if we select that side face, when we shelled this out, the belt hoop had an issue. This has some series of fillets, and the minimum radius curvature was lost, maybe perhaps even at this point. And so it might create bad geometry for mold making. And in fact, actually, it's bad geometry for mold making anyhow, because it's an undercut. Mold, typically, the most basic of molds are two-part. They have one half here, and they split. And notice this hooks over. The mold couldn't split very easily there. Now, there are ways of getting around that if you have to have it like that, but clearly we don't need it like that. Another, so meaning we could basically fill it in if we wanted to. However, filling it in isn't always a good thing either, because when you fill in, and now we're talking about plastics engineering and design, that thick of a piece of plastic, you'll get sink marks. It'll actually sink in because it solidifies, and the more material that you have, it sinks in even worse. You might not want that. We don't want the part to be warped because it's sinking in. So you want to keep what they call a core inside there to keep the walls thin to prevent the shrinkage from occurring. So here's what we're going to do. Select this side face, start a sketch, and draw, actually hit Convert Entities. That projects all the edges on the inside there to sketch geometry, as you can see here. Now take the line tool and click in here and draw a little box like this and have some geometry similar to what I have. So I'm going to go ahead and dimension this. Let's see here. We'll have it go in 0.03. Oops, I'm sorry, 0.3. And then we're going to go ahead and add an angle here. And what we're trying to add, actually I accidentally selected, I'm going to cancel that. Selected the point. Let's go with 120 degrees here and 120 here. And what I would normally do is I would actually put draft on using angles, but we'll just do it this way just so it's easy to see, and add some dimensions here. So, and then the bottom here, we'll go ahead and make that 0.125. And then position this endpoint to this edge right here, or that point, and go ahead and make that, make it 0.14. That's to locate it. Okay, now we want to cut this little segment out of here. And by the way, these numbers I'm just coming up with off the top of my head. In reality, I would think them through a little bit more than this. Okay, so now we've opened up that little segment right there. I went to trim it closest to open that up. I know it's hard to see, but now when we go to Features, Extrude Boss Base, we'll select this corner to go up to, hit the green check, and now we have our core in there. We could put draft on the sides too, which you'd probably be required to so that the core can pull out easier. Not all the time though. Plastics sometimes are a bit more forgiving, but in a case like this. All right, so we have it shelled out. We have our core in there. And it probably fixed any sort of issues there might have been in that little undercut area. And it will pull from the mold easier too. Now select this face and start a sketch. And we're going to use offset entities. And 0.05, hit reverse to get it on the inside there. And then select this inner edge and hit Convert Entities. Now, I know I showed you a trick where I didn't convert that inside edge, and that works great for linear geometry. Sometimes with the spline geometry, which is a little more freeform, sometimes I've seen some strange phenomena occur. So I'm going to close this gap. That's why we have those two in there. Now go to Features, Extrude Boss Base, and we want to extrude this 0.1 in height. And then also, we could turn the draft on too if we just set it to 1 degree. Now, if you see that it fails to show a preview, that might be an issue. So turn it off again. Yep, when we turn it on, we seem to have a bit of an issue. So we're going to leave it off. You could add it later with the draft tool. So hit the green check. And now we have our lip in there. Now to add it later, there's a draft tool right here. We'd be able to select the faces. Let's see if it works. Go to Draft, go to the Manual. The Draft Expert's very nice. In this case, it's such a simple little area. I'm going to go to Manual. Neutral Plane, select this surface here. And then the Faces to Draft, we'll select this surface right here and this surface here. And make sure we see the preview of the arrow. Let's see. There it is. I had to zoom out. It's way back here. As long as it's pointing outward, we're in good shape. Let's hit the green check. And now it should have added draft. Now, if we want to check, you could click on draft up here. I'm sorry, hit cancel there. You could go to evaluate, and there's actually draft analysis. And this is very useful for mold makers because they have to make sure there's draft on most every face so it pulls out of the mold properly. And here we have draft analysis parameters. Let's turn it up to 1. We didn't put much draft on here. Select this face. And you'll see green is positive draft. That's good in this case. We have a lot of green. Now yellow requires draft. So if we wanted to, we need to put draft on those faces and it calls that out on us. Red, negative draft, don't panic. That's not a bad thing as long as it's on the opposite side. And here you can actually see those faces need draft too, but we're not going to put that on. You just saw a method of putting draft in. We know two methods now while you extrude, and sometimes it doesn't work, especially with a spline contour like that. Sometimes we have some issues, so you could add it later on. Anyhow, this isn't a draft mold class, but just wanted to talk about that. All right, so now we're going to go ahead and let's go back to the assembly. Now to go back, first of all, you could save this part and hold Control and hit the Tab key one time and then release it. And it should bring you back to the assembly. It wants to update it, so just go ahead and hit yes. And so it has the changes we've made to it. The next thing we want to do is we want to get the battery cradle. See here, this red surface, these red surfaces are the battery cradle that are attached to the circuit board. We want to mimic that on the side of our cover so that the battery is held in place securely. And notice there's not many sharp edges on the actual rear cover to make dimensions to. So this is where top-down assembly modeling shows you its magic ability. What we're going to do, we're going to select the floor of that shelled out part there, start a sketch. Now I'm going to hit the space bar and I'm going to go to front view orientation, and I'm going to proceed to go to the hidden in gray, or hidden lines removed I should say, and zoom up. And here is at the bottom, it's somewhat hard to see. Maybe if we go to wireframe we might see it better. Maybe not. Let's go back. Okay, what we're seeing here, this is the battery, the edge of the battery, and there you can actually see the tip of the battery. So it's going around here. Now that's this little, what looks like the Roman numeral 1, or the letter I, capital I, is the battery cradle. We want to capture the two ribs here and here. Now here's how to do that. Click on the little arrow to the right of your rectangle tool, find corner rectangle. Hover over this corner right here when you get the orange dot. You have to look carefully. I'll hold it there for a second. You can pause if you need to look at it. Click. Drag across to this point here where it ends. Click. Same over here. Find the orange dot there. Click. And over here, click. And then hit escape. Didn't even have to use any dimensions. We just actually drew right over the geometry and it's tied to it. Now if you rotate, now you can see in there. And in fact, we should probably go to shade with edges now. And you can see our patterns at the bottom. They're ready to extrude. So go to Features, Extrude Boss Base, and we could just click on this vertex of the red cradle that's mounted on the circuit board for it to go up to. And then you can see it's going up to it. Now, some of you might say up to, couldn't you have selected up to next? Up to next wouldn't have been an option because up to next only looks at its own volume. This is a separate volume, so it wouldn't see it. It'd be blind to it. Hit the green check. Now we need to make the cutout, scallop cutout for the actual battery, the half round. So select this face here, and I'll zoom out so you can see that. There's the battery. Click right here. You're going to start a sketch, and now hit your space bar and go to the bottom view orientation. And there we could actually see the battery. Now go to sketch, go to the circle, and hover over this edge. And I think it's going to make us actually, although there it goes. I hover over the edge, and there's the center point. Now I could click on that center point, drag it out to this red corner right here, where the red corner meets our rib that we made. Click. And notice it's a little bit bigger than the battery. There's the battery. We have some clearance. And remember, with batteries, they can vary, especially temperature. If the batteries get really hot, heat expands. So you want to have some decent clearance for that battery. And now we could go to Features, Extruded Cut. And here's where I get a lot of students who select the wrong side. They select this corner. Remember, you wanted to go all the way through, but not all the way through the other side. So find the far end, the furthest red little marker there, click, and hit the green check. Now we should be able to, if we hold Ctrl and hit Tab, it should bring us back to our part. And look at that. We have our 2 ribs completed. And notice we hardly had to use any measuring. We used all the tools like up to vertex. We used the profiles we just sketched out. And this is like extremely accurate up to 8 decimal places. So just be aware, it's a great technique. Top-down assembly modeling. You're looking at the strengths right now very quickly. We didn't have to take any measurements. Just put them right in. Now hold Control and hit the Tab key. And from here, we're going to go ahead and bring back, actually we could turn off Edit Component because we're done with that rear part. And then click on Original and go to Show Component. Let's hit our spacebar and go to Isometric. And let's explode it now. So go to Exploded View. Select, let's see, we want to select this transparent part. Does anyone remember how to select it? Notice it's selecting through it. And we learned this a couple weeks ago. There's a key on the keyboard that allows you to select transparent objects. It's the Shift key. So hover over it again, click, and now that's selected. Now you can release the Shift key, get over the Z arrow, make sure that Z arrow turns blue, hold your mouse button down and drag it forward. And we're metric, so we'll bring it about 230 millimeters out, approximately. Then hit Done. Now you could click on this, which is the LCD, get the Z to turn blue, the Z arrow, and drag that out. You could drag it out a little bit further, maybe 270. And remember, you can zoom out if you need more room. Hit Done. Now let's go ahead and click on the purple part. Grab the Z, drag it forward about 100. Hit Done. And we'll start to drag these parts backwards. So click on the rear cover, go to the Z, drag it back about probably 250-ish around there. And now you know we have a battery in there, so you could rotate, hit Done, and rotate around and then see that battery, click on the battery and go to Z, drag it. And then you could also go to Y. And let's say we want to drag it down or up. Okay, in this case, it did something I wasn't expecting. So I'm going to hit the undo button. I'm going to hit Done, click on the battery again, and drag it down. Now, do we really want it there? Not really. I just wanted to show you how you could drag it in different axes. All right, now grab the circuit board, click, and now look what it did there. It moved that as well because we never hit the Done. So let's hit Undo, hit Done, and now we can move that. Drag that this way. And what we're going to do here is once you got that, go ahead and grab this right here. And we could drag that around. Actually, we probably have to hit Done again. Let's hit Done, click on it, grab this little arrow and drag it around so that we could flip it so we can see the circuit board. Now in real life, would we do that? Probably not, only to show the circuit board there. But hit the green check. Okay, so now we could see the assembly. And let's go underneath Exploded View. Let's go to Exploded Line Sketch. And what we can do for this, let's see. If you don't have a nice cylinder or an edge, like we do have edges here, but here we could actually select maybe this and have that go to this. And notice it kind of zigzagged around. This isn't the best example since I flipped around the circuit board, sadly. But hit the green check and you get the idea. So if you need to make additional entities like that, it's just selecting the edges. Like actually we could add one over here. Select this and then go ahead and probably have to get around to the back side. Select that edge right there. There we go. All right. That's pretty good. Hit the green check. And now let's collapse it. So to collapse it, right click up here, hit collapse. Now there is actually animate collapse too. If you go ahead and try animate collapse and you'll get to see it reassemble. So if you hit reciprocate and there's playback mode of half that speed or twice that speed, hit play again and you'll see it will go back and forth. You can slow it down to half speed. And then you could record it. You could hit save animation. And if you save the animation, you could select a series of, there's actually different, there's flash video, macroscope video. So there's a number of on here. I'm not sure if you have all those, but I'm going to hit cancel here. Just note you have those options. Okay, so we're done with that. Now the lab that's in the training guide. If you look on page, let's see here, we're on 96, and I rotated it. Remember, if you download it, then you click on it. You usually right-click and you'll find rotate, or in this case in Firefox, rotate is just right over here. Depends on what browser you're looking at. You might get the option to rotate. And we can see here, this is a cylindrical part, and the tricky part here is the sketch. Now, I'm not going to go through every single dimension. I actually did give you duplicate dimensions because it depends on what types of, the way you draw it. It might come out a little bit different in terms of like which dimensions you add versus a relation or constraint. Let's zoom up a little bit here. This is what it's called as a fictitious part. It's a turbine filter. And so these are basic little veins that are here that we're going to cut out last. Notice there's a hole that's patterned here. And whenever you see this in parentheses, like for a 1/4 inch binding head machine screw, that means you don't have to plug in all those numbers. You could actually go to the hole wizard, which we learned in exercise 4, and find a 1/4 inch binding head machine screw counterbore and put it in, and it'll actually find it from a library. And so you don't have to put all those details in, and it'll put it in exactly like you see it there. So be aware that's a nice feature. Okay, but we have here, it's 9 inches overall. I have a cross section through it, and there's these details. Now be careful with the details. The holes or the counterbores, remember, you don't draw those in. Those are going to be put in last. So let me show you a technique here. And I'm not going to put in all those dimensions because I want you to do it. Right now we're already near the end of the semester, and I'm going to give you little tidbits on how to get it if you get stuck. But at this point, I expect you to be doing these on your own. And as I always say, when you get a job doing this, there ought not to be any surprises that there's not going to be a video to show you how to do your job. So that's why I insist that you learn to do these on your own. All right, I'm going to start with the, let's see here, front plane, start a sketch. I'm going to go to the Centerline tool, draw that up. And I'm going to draw a line across here just for scale, because if you remember, it's 9 inches across, so about 4.5 inches. That would bring us to for half. And that vertical center line is there because we need to revolve it. Okay, now you have to look very carefully at these models or these drawings. And as you can see here, we have a hole that's 2 inches. And so that's going to be 1 inch off of there. And it's off of the bottom edge. It's positioned a 1/2 inch. And then the overall thickness here is going to be 1.5. So we could actually draw that in. So something like this. Let's put some dimensions again to give a scale. The hole is going to be 2 inches. So we'll get that in. And then from here to the base, it's going to be 0.5. Let's hit escape. And I might actually have that wrong. Let me go back to that drawing. Oh no, I'm sorry, I have that wrong. It's actually 1.5. All right, I was wondering why it's turned out so small. And one last thing there. It's going to be it's 1 inch. It's going to be 1/2 inch off the base. So by putting this in, this little bit of work is going to make your life a lot easier when you're drawing this out. So let's get that way over there. Okay, so we have that now. Now we just go over here to the line tool, and let's just verify. It goes across, and then there's a jog of 35 degrees all the way down to the center line, and then a short little area there across, and then an 18-degree dimension there, and then this goes, looks like it goes straight up. Then there's a little jog of 53 degrees, then it goes down 4 degrees off angle, and that you're back to that 118, and then straight across, we get in there about a 1/2 inch up, and then connect. So let's do that. So we're going to take this, go across like so, about 2 inches, bring it down, across, up, that was that 118, and then it goes straight up. And there's a little jog here, about 50-something degrees. Now, if you don't want to accidentally get an angle, see it's going to some angles, remember the trick is the Control key will disable auto snap. Just for a moment. And then there's about 4 degrees of draft here. And then we've got this. And again, I'm going to use the Control to disable the snaps. Going to go across here, up, and we do actually want to snap to that. There we go. And let's get that stretched out there. So the Smart Dimension, get this to here. That's supposed to be 9. Now it's going to jazz up our geometry a little bit. But if I hit escape, I can bring this back down. There we go. And then we know this is going to be 4 degrees. And this is from here to here. I believe that was 52 or 53. Let's go check that out. 53. And this is 18 degrees from here to here. Make sure you get it in the little areas that I'm showing you here. If you drag it out here, you're going to get the opposite. So be aware of that. Okay, and then we have 35 degrees for this angle to the center line. And I'll straighten these out in a little bit. And let's see what else we got here. 35. I think we're in pretty good shape. Now we just have to put some additional dimensions. We could see this needs to be 1.5 off that base. So from here to the center line, that needs to be 1.5. Or we could mate it with instead of having dual dimensions like that. Oh, here it slipped out of there. We just hit escape. I drag it over. And there are some dimensions here. Let's see. That bottom line is a 1 inch. Okay. And notice the colors are changing. They're turning black, and black is good. That means it's fully defined. The blue is what we still have to define. And okay, now we need to get that corner, which is right here. Follow that up. That's going to be 5 inches. This is 3 inches off of here. So let's start work our way from the inside out. So from here to here, remember, cross the center line to the right, make that 3. This point to the center line, cross the center line on the right, it's going to be 5. And then we have 8.5 for that point. So from here to here, this will be 8.5 to the center line. And we have the 9 already in there. And let's get these aligned here. Get them out of the way. Okay, now the height, we have a 2-inch from this face here to the top of that. So from here to this face will be 2 inches. Okay, and again, we have it get thrown off a little bit, hit escape. You could hit undo if you wanted to constrain this in a different manner, but this should take care of it. You could just drag things around and get them relocated until we get more dimensions on. Oh, we have a 37-degree angle there. Do I have that? No, I don't. So let's put that angle in. So from here to here, that's 37. Okay, we only have 2 blue lines left. Let's see what we need for those. This should be 1 inch off of this face here. Okay, 1 left. Just that one right there. That's blue. And what are we missing? You see the corner is 1.75, or here, yeah, we actually have that dimension if we follow it. 0.25 off of that face. So from here to here, 0.25. Now it's fully defined. So this is where I would recommend laying this out. And these are important. You could actually add your diameter symbols to these. You just hit escape, click on the arrows for those. Stay away from the actual dimension or else that happens. Here, we'll actually just group select those. And then go to diameter. And now we could lay those out a little bit better. Got the 53, the 4 degrees right there, 0.25, 1.5, another 1.5. And there are better ways of laying this out. I'm just trying to get it to match up as easily as possible. Remember, this isn't the drawing, but for the drawing later on, you might want to lay those out even better, because that's very difficult to read. Okay, but for the most part, you've got them laid out, and that's what's important. It's easy for, not easy, but it's easier for the person modeling this, because remember, change occurs. They could go in and they could see it a little bit easier. So always lay them out in such a way that might look easy to string. All right, let's go ahead and click on the center line. Go to Features, Revolve Boss Base, hit the green check. Okay, looking good. Now for those holes here, let's select this face and start a sketch. And what I'm going to do is I'm going to put a bolt circle in for ease of use. So we have a bolt circle here of a radius of 2 inches. It would actually be a diameter of 4. And then the quadrants. So let's go to the circle tool, and at the origin, draw a circle and smart dimension it at 4 inches diameter. And now while we hit escape, select that circle, and right here you could turn it to construction geometry. or check the box over here, construction geometry. So now it's dashed. And let's go to normal to that face. And we could go to features and hit rebuild, by the way, and it'll stay in there. So we're in good shape. Now we could go to features and we could actually go to Hole Wizard. Now it is a counterbore that we're seeking. And let's look at that drawing again. It's for a 1/4 inch binding head machine screw. So we're in binding head screw size, find a 1/4 inch. There it is. The end condition should be through all. And it should be standard, whatever the defaults are. So now we go to position, and we should be able to click on this face and find the quadrants for each one of those. Now we could do a pattern, but I just want to show you how you could just click and add those holes. Hit the green check. And there it is. Okay, now select this face, start a sketch. And let's go back normal 2. And now we have to put in the cutouts to make those veins. So I'm going to start with a center line at the origin. All right, so now as we look here, we can see, if we zoom up, we have those cutouts and they follow this pattern. Oh, there's also a keyway that we have to put in, so we can't forget that. All right, but at the base here, it's 0.1 at the base for the width. It's centered, and then it's spread out in 3 degrees. So if we did something like this, where we go off that edge, and let's put in 3 degrees between those two. So Ctrl select. And, oh, I'm sorry, just go to Smart Dimension. From here to here, 3. And then from the base to the center line, just make sure that's 0.1. And now you could Control select, after I hit Escape, Control select the center line and that line that you want, because we're going to mirror them. Now right here, just put a little straight. And let's go to Features, Extrude Cut, and we're going to go through all, both. Actually, it just needs to be through all, doesn't need to be both, but let's see. Hit the green check, and it cut a little sliver in there. Now, sometimes you might have to flip it so it cuts the reverse side, but it did an okay job there. Now we just need to pattern it, so let's look at the drawing, and there's 27 of those. So select that cut extrude, go to circular pattern, we'll put in 27, select the outer face, hit apply, and we're almost done. Let's put the keyway in, select this face, start a sketch, go normal 2, and get that little, go to center rectangle. Well, let's first draw a center line. Okay, then go to, let's see what the parameters are before we add anything. Okay, so the keyway, the top edge is 1.1 cut out, and it's 0.25 wide. So let's get a center rectangle. Draw it out like so. Dimension it at 0.25 wide. And then from this top edge to the origin, 1.1. And if you want to make sure it doesn't accidentally screw up here, just make it at least 0.5. Something that we know we'll always make sure it goes through. And go to Features, Extrude Cut, Through All. And I believe that completes this exercise. Now, I would recommend that you make a drawing from this, so we could go ahead and make that drawing. Front, section, right, back, and isometric. So I'm going to let you do that. And that concludes exercise 10 and lab 10.